flat plate that's sitting in the flow itself and bending. What are the other types of methods to determine yield? We mentioned weighing. Impact plate, weighing.
Like light reflectance?
Light reflectance. It's more of a volumetric measurement system. And this volumetric measurement system utilizes photosensors. Put it right here. And so you have a photosensor here as this elevator. As this elevator is coming up. So as the material's coming up through this elevator, there's a photosensor that shoots across. And if you can't see and it can't see the light from the other side, that means it's full of stuff. If you can't see the light from the other side with some sort of photoresistor or whatever, that means it's air there. It's empty. So it's a way of determining what's the percent volume filled in that elevator. That's commonly used for what crop?
Cotton.
Cotton. And the person that actually developed that is in our department. Dr. John Wilkerson developed a cotton yield sensor that's used on a lot of Case IH and other types of combines, utilizing photosensors and a volumetric type of flow rate, not a mass flow rate. Okay, what's another way of determining yield? That's three. This technique is very common in Europe, especially with Kloss combines, German combines. Well, it was in the reading, and it has to do with radiometric techniques. And the radiometric technique is typically nuclear. They have some kind of isotope that's outputting some sort of radiation. Ooh, that's almost like a dirty word. And it is, and a lot of these are cesium sources. It doesn't say in here. But a lot of these are cesium sources, and you have a source here of cesium, which outputs photons, which is way a lot of people measure soil density technique. And this cesium, the photons shoot through this stuff, and a lot of them hit the particles and attenuate or lose energy. And the Geiger counter, some kind of counter over here, picks up all the incoming photons and measures the high energy photons, indicating that some of the photons have lost energy. Well, the more photons that have lost energy, the more mass is going through here. Because if there was nothing there, none of the photons would lose energy. So you're actually shooting a radioactive source through a food product, and you're measuring the high energy photons on the other side. You can see why we don't do this here in the U.S. At least I can understand myself. First off, we have all sorts of everybody, farmers would have to be wearing film badges and go through nuclear training and all sorts of stuff. And then you've got all sorts of hazard displays on combines that would have to work. Now, I know Kloss has been doing this for a while. I don't know if they're still doing this, but it's still in the book on methods of determining the yield. But you don't see that here in the U.S. So those are different types of techniques to determine yield on the go. The impact force sensor is by far the most common. Now, the question I have for you, I have a question for you, and that deals with a problem with yield sensors. Because if we're measuring the yield at which the grain enters the clean grain auger, and we get that position, is that the position at which the grain was harvested? No. No. The grain was harvested way back there as I'm combining through my field. And as I'm going through my field, it goes through this whole process. In here of threshing, cleaning, transportation, until it goes across that impact sensor, at which point I measure that a fair amount of time later, and I measure the location of that. And that's a big problem with grain yield monitors, and it's called transport lag. And this has to be covered or understood. Now, I've passed out, and one of the things we're going to do is talk about transport lag in class. I've passed out a report from PAMI. PAMI, P-A-M-I. PAMI stands for Prairie Agricultural Machinery Institute, and they're out of Canada. And they're sort of like the consumer reports of ag equipment. So they get stuff in, they evaluate it, they test it, they write a little report, and now these reports are available to anybody who's thinking about buying a yield monitor with a GPS receiver. Now this describes the process and the evaluation of 3 yield monitors and GPS combinations. And we're going to go through this and talk about this, because there's an evaluation process and a test process that you haven't looked at. The 3 units are Deere, Case, and a company called Ag Leader. On table 1, they have an AFS, which stands for Advanced Farming System, which is a Case IH product. Ag Leader, which is they don't make tractors or combines, but they make sensors. And Green Star, which is a John Deere product. And actually, that's for the evaluation. Now, how many of you guys are Deere fans here? Anybody likes Deere equipment? Ezra? Will? Okay. Ezra and Will are going to defend and discuss the John Deere equipment. Okay. Who wants to defend the Advanced Farming Systems case? I need 2 volunteers. Okay. Brett and Corey are going after Advanced Farming Systems. You other 3 are going to be assigned to Ag Leader. So when I present the material of Deere, I'm going to show the graphs, and I want, depending on what combine you've been assigned to, I want you to provide some discussion about how good it works or how poor it works. And a lot of it's in here, too. Okay. We'll probably do that Wednesday, tomorrow. So take a look at this. If we don't do it tomorrow, we might do it on Monday. We may not get to it. Matter of fact, let's go ahead and do it on Monday. That'll give you a little bit of time to look at that. And Wednesday we'll go with the sprayer stuff. But I want you to read through here, see how they've evaluated the yield monitor, see how they've talked about transport lag, GPS accuracy, ease of equipment, and really it's the transport lag part of it that I am going to focus on. All right, so take a look at that. This is a research update, PAMI. It's really a consumer reports product. Okay. Now, what I want to do right now is talk a little bit about your assignments. Because we have, let me grab my assignment right here. And I'm not putting a due date on this yet, because you guys are working on an assignment right now. We got a test on Tuesday, and it won't be a week from when, it won't be next Wednesday.